Okay, let's jump right in. Today, we're going to break down this really fascinating new paper that puts forward a simple, practical, and, well, an operational rule for what we call consciousness. It's an idea that tries to cut through centuries of debate with a single, really elegant test.
I mean, it's the big one, isn't it? What is this inner world, this private experience we all have? It's a mystery that has stumped some of the absolute greatest minds in science and philosophy for as long as we've been asking questions.
Way back in 1995, the philosopher David Chalmers famously gave this a name, the hard problem. And it really is hard. How does the physical stuff in our brains, neurons, chemicals, electricity, how does that give rise to this subjective feeling of being you, the experience of seeing the color red or tasting salt? It's a massive challenge. And this is where this paper makes a really clever move. Instead of trying to solve the hard problem of inner feeling, which, let's be honest, might be impossible, it pivots. It asks a different question. Can we create a simple, measurable rule for when a system is using information in a way that looks and acts conscious? To do that, the paper insists we have to separate the problem into two very distinct questions. And this separation, well, it's the key to everything. It's what unlocks a practical way forward. So on one side, you have access. This is the stuff we can actually measure. Can a system take in some information and then report on it or act on it? Then on the other side, you have experience, that private inner feeling, the whole hard problem. This theory basically says, okay, let's put experience to one side for a moment and just focus on creating a concrete test for access. And to explain this test for access, the paper offers up this wonderfully simple and intuitive metaphor that, honestly, anyone can grasp right away: a prism. Just think about how a prism works, right? You have all this scattered light coming in. That's like all the different inputs and signals the system gets. The prism gathers that light, it holds it for just a moment, and then projects a clear, unified pattern onto a screen where it can be seen and actually used. This simple image is the entire foundation for the theory. So this brings us to the core idea: join, stabilize, use, or just JSU for short. The theory says that we can call something conscious access whenever we see these three things happen together for the same piece of information. So, let's break that down. Right. So what do these three steps, join, stabilize, and use, actually mean? This is the practical engine of the whole theory, the part that turns that cool metaphor into a process you can actually measure. First, all these different signals, sights, sounds, maybe some memories, they have to join together into one single coherent pattern, a scene, if you will. Second, that pattern has to stabilize. It's got to hold steady for a brief window of time. It can't just get overwritten immediately. And third, that stable pattern has to be used to actually influence what the system does next, like making a choice or saying a word. Now, what's so cool about this, and what you're seeing here, is how it makes the whole theory concrete. For that join stage, you can literally look for a tiny, quick change in someone's pupil. For stabilize, you can measure if their reaction times are getting steadier. And for use, well, you just look for an accurate report or a correct choice. Suddenly, this super abstract idea becomes something you could almost test in your living room. And this process isn't just a one-time thing. It's more like a repeating clock. There's a quick burst where all the signals join up. That's followed by a brief plateau where the information stabilizes. And then it's used. This three-step loop just happens over and over and over at a whole bunch of different speeds. And this is where the theory gets really mind-bending. The authors argue that this exact same JSU rule doesn't just apply to human brains. They're saying it applies everywhere, across totally different systems and wildly different scales of time and space. And you can see just how incredible the scope is. The same join, stabilize, use pattern could describe chemical reactions happening in microseconds, our own attention spanning a few seconds, the comfort level of a room stabilizing over minutes, or even the habits of a group forming over days. It is one single rule that could apply to all of them. To really drive this home, check this out. Compare a human doing a simple task to an entire bee colony. For you, sights and sounds join into a scene. You stabilize it for a moment and you use it to speak and answer. For the bees, things like heat and scent join together, the colony forms a stable cluster pattern, and they use that state to do something, like share food. The underlying logic? It's identical. So what does this all add up to? Well, the real power of this idea is that it gives us a practical, measurable toolkit that science and engineering can actually work with. But first, and this is so important, we have to really emphasize this. JSU is a test for access. It's a test for when a system can demonstrably use information. It makes absolutely no claim, zero, about whether that system has a private, inner feeling. It just elegantly sidesteps the hard problem. And that utility is the real takeaway here. JSU gives scientists a clear yes or no test, and it works across different kinds of systems. The paper calls it substrate neutral, which just means it doesn't matter if it's a brain, a computer, or even a beehive. Best of all, you don't need fancy lab equipment to start. You could begin testing for it with simple tools like a phone camera. This could open up huge applications in medicine, say for assessing disorders of consciousness, or even in AI design for building more accountable systems.
And that's the powerful payoff. The theory's goal is to completely transform the conversation. Instead of getting stuck in this endless, maybe unwinnable philosophical debate about what is conscious, we can now ask a scientific question. Did the system at that moment pass the joint stabilized use test? It's something you can test. You can prove it wrong. That's a revolutionary shift.
And so that leaves us with a pretty provocative final thought. If a system, and it doesn't matter if it's an animal, an AI, whatever, if it can reliably show us that it joins information, stabilizes it, and then uses it to act in the world, what does that imply? It might not tell us if it feels anything, but it really forces us to ask, at what point do its actions become something we have to hold accountable?